So, good morning to everyone. My name is Lior. I'm happy and excited to be here. And what I want to talk about today is basically leveraging AI, this technology of LLMs, beyond just coding, but still in the realm of software engineering. And I think most, if not all people here have had, and myself included, have had this experience in the past 2 or 3 years where we just type something in English and we let the coding agent just spit out the code and it actually works. So it's a wow or aha moment. And at this point in time, I think we can acknowledge that LLMs can code pretty well. And if it's not something, there's still improvements to be done, but they're done every day. And it's pretty much a solved problem in terms of actually coding. But for anyone who's been in this for more than a week, we already know that actually producing software consistently, not trivial software, but something bigger, it requires more than just the coding. Coding was never really the bottleneck when it comes to software delivery. Okay. And I think this is a key point because we are already feeling the improvements in velocity. Okay. We know, and I'm not going to go into the discussion of how we measure productivity in software engineering, but let's assume for a second that we already know we're improving, we're doing things that we could not have done before with LLMs when it comes to writing code. But delivering software is much more than just writing code, like I just said. And even if LLMs and the technology, the tools around it continue to improve, I think we still need to address, we really need to see more leapfrogs of productivity. We need to really look at other problems in the software development lifecycle. Specifically, what I want to look at is how we do system design, because that's what I usually do in my work. And when I talk about system design, I'm talking specifically about system, not so much software design. So not so much design of the code itself, because again, I think coding agents have pretty much solved this at this point. But I'm talking more about the system as a whole, right? What are the components of the system? Where does the data reside? How do we enforce security? How do we maintain performance? And all these kind of things that go into actually delivering production software. Okay. And the question is, can we do this with LLMs consistently and of course at scale? And when I say scale, I'm in fact implying automation. Okay. Can we use to do system design? Now, a naive approach would be to, let's just spin up ChatGPT or Gemini or Claude or whatever, and just give it a problem, describe the problem, whatever context we have, and ask it for an answer, ask it for a system design. And we could do that actually, but we know when we use just a single LLM, we know we have limitations. We know that LLMs tend to be confident. They tend to anchor to the first solution that they have. And with this kind of problem, system design, where we're balancing trade-offs, we are asked, what we need to do is actually consolidate or somehow balance different forces that are at play. Not all of them are technical. This approach is probably not good enough. And another thing is, we can probably use an LLM, especially if it's a good one or the frontline LLMs, to do brainstorming together with us. But then we're missing the point about doing this automatically and at scale, which actually brought me back to thinking, how do we humans actually do this kind of system designs? And the way we do it in practice is it's a team effort, right? When we're doing this kind of system design, again, I'm not talking about toy projects or simple enough projects. I'm talking about production software, moderately complex. Then we do it together with other people. Either we sit in a room and draw on a whiteboard, or we have a draft document, the diagrams that we share with other, and then they give feedback and we have this discussion. But whatever the point is, we have different people with different skill sets, different motivations sometimes. Sometimes we have heated arguments. But the point is, there's a lot of people involved in this process. And there's also a dynamic and a way to somehow consolidate the different opinions and eventually get to some kind of decision, whether it's just the architect or the manager or the CTO just saying, this is the way we're going, or it's a vote or whatever. Okay. And then the thought came up, what if this is actually not a bug in a sense? It's the feature. This is how it's supposed to be for this kind of problems. Okay. And how can we translate that dynamic or that way of doing things into the world of LLMs and of course allow it to be scaled? So instead of asking the LLMs for an answer, I'm asking the LLMs to actually do the argument among themselves and eventually get to an answer, of course. And it turns out that there is such a pattern of using LLMs. I did not invent it. Okay. Multi-agent debates is a pattern. It's been researched in recent years. If you look at the slide notes later, you can see links to specific publications around it. Maybe there are more that I didn't find. That's fine. And there are actually, there are different, let's say, variants to this pattern. It's not an exact pattern, but the variant that I think is more appropriate to this kind of problem is, I don't know if you can see my pointer here on the screen. So we have different agents, each one of them with a specific, let's say, role or persona, if you want, and configuration. And they get the problem, all of them get the same problem in context, and they give a proposal of a solution. Then each of them basically provides feedback on the other agents' proposals. Note that each agent has their own, let's say, angle or a facet or perspective on the problem. So they give the feedback from their perspective. Then they get the feedback from the other agents and they refine their proposal. And this goes on for several rounds. Okay, I don't know if you can see my cursor here, until at some point it converges into a solution. So we have another LLM that basically takes all the final proposals and produces an actual proposed solution, at least a draft. Okay. And basically this pattern of multi-agent debates is composed of three, let's say, components, main components of the pattern. The first one, here you can see it on the left, is basically the agent profile. So each agent is configured with the facet, the perspective, how to look at the problem, how to look at the data, what to focus on. It can also be a technical configuration, like what underlying model to use and some other parameters, etc. Okay. The second component of this pattern is let's say, the communication structure or the topology. So who talks to who during this debate? Does everyone give feedback to everyone else? Do I give feedback to specific agents, etc.? And the third one is basically the convergence mechanism or the decision rule, if you want. How do I know when to stop the debate and actually reach a decision? And how do I get to a decision? Now, like I said, this has been researched and with different kind of problems, and each of these components has slightly different variants. For example, when you do multi-agent debates for math problems tend to have a deterministic answer, right? It's either 5 or 3 or 8. And the decision rule in that case is usually simple majority voting. So the answer that got the most votes from the different agents, that's the answer that we're going to give. In the case of system design, there is no fundamentally correct answer. There is no single truth. It's, like I said, trade-offs, a bunch of trade-offs. So we're probably going to need to use something else. And this is exactly why I think this pattern that I just presented is actually fitting for this kind of problem we're trying to solve. Because in system design, it is generally what we're looking for is we're looking for the other person when we do it, for the other person to validate our assumptions or maybe point out some blind spots that we have. And generally speaking, when we're doing this, when we want to do it with LLMs, we're looking for this kind of adversarial pressure, right? That we want to have them amongst each other. And this is why this debate pattern actually, I think, fits this kind of problem, okay? A problem where you don't have necessarily a single correct answer, when you need to balance things And this is why I think it works. So I have actually went ahead and implemented this pattern. So this is a tool, I call it Dialectic, and it's basically, there are different versions of it. I'll touch on this in a few minutes. But the first version is basically it's invokes using a CLI. And in this tool, you have the option to basically configure, have different roles, I call it, that you can, which are basically different ways to configure your agent to different perspectives. So you have the data modeling expert, you have the security expert, the performance expert. You also have the person who's I called it, it's called KISS, keep it simple, because it's like the simplicity advocate, the person who advocates for a simpler design. And what this tool does basically is it implements this protocol which I just described, of this proposal, critique, and then refine in rounds until eventually it gives you a finalized design recommendation. And you can also see the evolution of the debate and the different proposals, critiques, et cetera, et cetera. And you can also you also have a chance to look at the trace and technical issues, and you can get an automatic, let's say, design recommendation. Okay. One of my colleagues at work, where I showed them this tool, he called it, it's like having my own personal software consultant, third-party consultant sitting in my laptop, which is nice. Okay. Now, I don't have time to show you a demo because these debates, they take time. Just to give you a taste of how it looks, this is actually, okay, you can't read everything here. Honestly, I can't read here, but this is the web UI. And forgive me because I'm not much of a UX designer, but this is, you can see here, I think it's enough to see here on the top left, I have it where I input the problem. I just describe the problem, the questions I want answers, and then I configure on the left side here, the configuration of the debate. I'll touch on this. So basically, how many agents do I have debating, how they are configured, and then I hit start debate, and then I see the debate running here on the top right. So I have, in this case, 3 agents. There could be more. And it's an accordion. You can look into whatever they do for each round, the proposals, the critiques, etc. You can look at them. This one ran for 3 rounds. And on the bottom right here, you can see the finalized results. So the actual design recommendation. You have a chance also to, of course, like technical things, like you can provide feedback if it's good or not. You can copy it, download, whatever. So this is roughly how it looks. This is the web UI. There's a CLI version. There's another version, which I'll talk about. And what it basically does behind the scenes is implement this protocol where there's an orchestrator that basically it first asks, so there's an option to give the agents the opportunity to ask clarifying questions, each from their perspective. So when you give them the problem and the context, so you can have the different agents ask for clarifications. So the agent, sorry, I'm talking about guys, but the agent that deals with performance might ask, okay, you said you want high performance, but what does it mean? What is the expected latency? What is the peak concurrent users and stuff like that? Same goes for security and so on. So they have a chance, it's optional, but they have a chance to ask for clarifications. After that is done, basically the orchestrator collects all the answers. So the human provides the answers to that. And after that is done, they go into this cycle, like I just mentioned, of several rounds until eventually you get a synthesis of the solution. And this is what you get. Okay, so this is a very high level view of how the tool works. Okay, without going into all the details behind the scenes. So I went ahead and actually also, it's not just implementation. I wanted to see, does it work? First of all, does it give reasonable answers? Maybe, again, not correct ones, but reasonable answers in the sense that does it cover the questions I'm asking? Does it give reasonable trade-offs and explanations on the design decisions and stuff like that? And I ran some tests. Now, a general disclaimer, these are not rigorous testing yet. These are not exhaustive testing. More needs to be done. Still a work in progress. And there are more follow-up questions that come up. But already there are some trends and insights. And basically, I try to play around with different configurations of the tool, see what affects the result in the sense of, does it provide me a reasonable solution? where I, as an architect, would say, okay, I can work with that, or this is completely hallucinated and not useful. And using LLM as a judge, as a technique, and then there are some success metrics to see whether it works. Now, again, I don't have time to go into all the results, or quite a bit. There's a link at the end to the website where you can see, and even in this presentation, there are more detailed slides, but there are already some insights that are interesting, right? First of all, when we provide clarification, the result improves, which is not that surprising because we're providing more context, more specific context to what the agents are looking for. So this actually improves. When we summarize, so there's a built-in mechanism for summarizing context because debates can run for a long time. So that actually degrades performance, which again, it's a naive implementation of summarization, I have to be honest, but we're losing context. So we're not that interesting. There's a question of how long should these debates run for? How many meetings, so to speak, when we do it? And it turns out that anything beyond 2, 3, maybe 4 rounds of debate is not that useful. We're not seeing improvement beyond that. Okay. So that's an interesting aspect of it as well. And roles, the actual roles participating in the debate, they do matter. Okay. So we see, for example, where we have the composition of the roles. So when we have a debate running without a security expert, the resulting decisions and the design does not address security and compliance as much as we'd like it. That's just an example, but it also hints at another, I think, important point here. An insight is that we can provide weight to specific aspects that we'd like to emphasize. So for example, if I am looking to have a design that is more simple, I would add more simplicity advocate, not just one, I'll add another one or maybe another 2. So they will give more weight to this aspect of simplicity, and the solution will trend toward a more simple solution. Okay. This is also something that came up during testing. And I think the key point here is that we have to actually design the debate. Okay. It's not so much just throwing an LLM at the problem or a bunch of LLMs at the problem. It's actually thinking about how we're structuring the debate. Who are we? How long does it run? And who are we inviting, so to speak, to the debate itself? Which again, is not that different from how we humans do it. Because when I run this kind of design discussion where I work, I'm thinking about who I want in the debate. And it's really possible that I will ask for a specific team leader from another team because they're relevant, or this guy has experience with this kind of problem, or I might ask for the DevOps guy who knows nothing about the application, but he's a really good expert on security. So I might want to bring him into the discussion and weigh in as well. So this is how I usually conduct myself at work. And this is how we should look at this when LLMs do it as well. So we should design how we're doing the debate itself. Okay. Yeah. Okay. I've hinted at this, and actually there's another implementation of this, of Dialectic, and I called it as an agentic version of it, which is basically implementing the same protocol, okay, but as a set of skills, okay? When I say skills in the sense of the files that are used in Cursor, Claude Code, and the other coding agents, right? So what it does is basically, it's a re-implementation of this protocol, but as a set of skills on top of an underlying coding platform. It has a lot of benefits in terms of the ability to use the underlying tools and the different implementation details. I don't need to worry so much about wiring and passing context, etc. So each of these platforms already supports running skills as sub-agents, so as different processes, etc. So it's easy to implement. It does come at a cost at some point because the orchestration itself is also a skill. It's harder to test it a bit because it's not as deterministic as code actually running it. And also it tends to be more, let's say, token intensive. So it's more expensive. Okay. But it has a lot of benefits as well. And there are more details, like I said, in the links at the end. The way it looks, so this doesn't have a UI. The UI is the coding agent, like the Cursor or Claude Code or whatever. So we have the different agents and they communicate with each other, at least in this version, using simple files. So they have a workspace, a specific directory. You can see it on the left here, and they read and write files. So they write the proposals, and the other agents read the proposal from that file. They provide the feedback, etc. This is all as markdown files on disk, and they read and write. So in terms of the underlying implementation, it's very simple. It's just file read and file write. And what you see here is basically just the markdown files. This is Obsidian running on my laptop with showing the file. So we have here a problem file on the top left, which is again a markdown file. Then here we have the file of all the clarifications, all the questions that were asked and the answers I provided. And then there's a progress log, which the orchestrator runs all the time. You can't see the writing here, but this one specifically ran for 50 minutes, 4 rounds. And then you can see here on the bottom right here, the finalized solution or the suggested recommendation for a design in this case. Okay. All the files are in disk. You can go into it and trace what happened, who proposed what and why, etc. So what I've shown you so far is a way we can do, like I said, system design. And this basically addresses another aspect of the software development lifecycle. And I actually want to go back to my original question, which is, okay, so we have this, and we also have different phases or steps in the software development lifecycle addressed by different tools, not this one. We have SpecKit, for example, for writing requirements and specifications. We have and other tools as well. And it's been 23 minutes. I'm sure there are 5 other tools by now since I started talking, because the rate at which this evolves is really staggering. We have tools to do design. I just showed you one, but I'm sure there are others. Coding agents, of course, to produce the code. And we also have LLM tools used for troubleshooting and testing and observability, etc. Okay, we've heard about some of them right here. So the question or the idea that I'm hypothesizing is basically we have all of these together. What would be our next, let's say, step in this direction? And I'm saying I think we can reach a situation. We're not that far. We're not there yet. But I think all the pieces are here where we have a human basically providing the requirements, also non-technical requirements, non-functional requirements, technical requirements. And then from there, it's only LLMs taking this and doing a design for a system, and then taking that finalized design recommendation and having another LLM produce the more detailed plan, technical plan, but also a plan on how to observe, like in architectural fitness functions, how to measure and how to monitor this. And then, of course, we have a coding agent that produces the code to observe, and of course, the functional code, whether it's a bug or a new feature. And then we already know for years now, continuous delivery and continuous deployment. So it's not much of a leap to assume we can do continuous deployment of these artifacts, which now results in a new system state, which is the context for the next bug or feature that we can develop. Okay, so we're having the whole process of the development, the evolution of the software basically mechanized. And I think, like I said, we're not there yet, but we're not that far as well. Okay, I think we can do much more with LLMs to mechanize this process and therefore scale it. Now, when I say it's mechanized, I do not mean that the humans are out of the loop. Okay, and I think humans have, even if everything, and at the most extreme, everything is mechanized, and we have a system that it evolves on its own automatically or autonomously, actually, humans still have a very important part to play. And first of all, in applying judgment to what gets built and when, to providing the business process, the business context for the software to be built, right? Driving innovation. Okay, this is also something that will probably still come from humans. Could be wrong, but I think it is. But there's also an important part to play here, in a sense, providing, in a good sense, friction to how the software evolves. There is value in governance, providing governance, to how the software evolves. We need the humans to be the guardrail for legal reasons, for social, because eventually software being developed affects people, affects humans, and we need to have these people. So I think humans, even if everything is mechanized, and I think it can be, maybe not in the short term, but I think it can be, we still need to think about how we are there. And I propose that this is the way to go. That's it, basically. Okay. This is just a short recap. You have here specific links to website, to the projects that I just described. Okay. Thank you.